In this video, I am going to explain clustering principles used in Internet of Things architectures and also explain the importance of clustering principles used in Internet of Things architectures. Let us consider IoT device, any IoT device. Most of the times the IoT device is involved in sensing the data, processing the data, communicate the data. Most of the IoT devices are involved in such type of operations. IoT devices are battery operated. IoT devices are involved in such type of operations. Some energy is consumed. Therefore, the lifetime of that IoT device is directly proportional to energy consumption. Energy consumption of the device. Sensing the data, processing the data, and communicating the data. Less energy will require for sensing the data. Medium energy will require for processing the data. More energy will require communicating the data from one point to another point. Okay. If you want to implement IoT architecture in any city, we need some IoT devices. These IoT devices are placed at different places of the city for any applications. Monitoring the traffic conditions. Here, some base station is there, BS. Some base station is there here. This is a device 1. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 devices. Hundreds or thousands of IoT devices will require for processor for gathering, analyzing the traffic conditions in our city. In this example, 12 devices are considered. It is for each and every device sensing the information and send the information to base station. That is the general requirement. That is called as one-hop communication. The device, IoT device, generally sense the environmental conditions and process the data and finally communicating the data to base station. That is the difficult task because the most of the times IoT device is involved in processing the information. Therefore, the energy is wasted. Finally, the IoT device is converted into dead condition. That is the reason. Divide the sensor nodes into groups. This is the group. These are the sensor nodes. Here some sensor nodes. In one area of the city, divide the IoT devices into groups is called as clusters. Okay. Here 4 IoT devices are there, or 4 IoT sensor nodes are there. Here 5th one is also there. This one is the cluster head. These 4 devices are select one cluster head. These 4 devices directly send the information to cluster head. Here 1, 2, 3, 4, 1, 2, 3, 5 IoT devices are there. 1 cluster head is there. These 5 IoT devices are directly sent to information to cluster head. Only cluster heads are responsible to send the information to base station. Therefore, by using this clustering principles have to reduce the energy consumption of the each and every IoT device which are placed in the different parts of the city for general in any application. In our example, the application is monitoring the traffic conditions in our city. This one of the major constraints of the IoT is that sensor nodes have limited power sources as they are operated in small batteries. These are the IoT devices having limited power sources as they are operated on small batteries. They are operated on small batteries. In many applications, it is impractical to replace the batteries or sensor nodes due to harsh environment. Due to some in different areas are there. In some area, it is it is easily to replace the batteries. In some areas, it is very difficult to replace the such batteries. That is called as a harsh environment. In many applications, it is impractical to replace the batteries or sensor nodes due to harsh environment. Energy consumption of the sensor nodes, that means IoT devices, is the most challenging issue for the long run operation of the IoT networks. Clustering divided the IoT devices into groups is called as clustering. Clustering will be beneficial to reduce the energy expenditure, improve the scalability, robustness of the networks. Clustering means it is scalability means it is easily add the devices to new devices to clusters. That is called as scalability. Robustness means the IoT device has the ability to withstand in any conditions. That is called as robustness. Clustering will be beneficial to reduce the energy expenditure, improve the scalability. Scalability means add the devices to the clusters is very easy compared to other analysis. Robustness means the device has the ability to withstand in any condition is the robustness. Clustering is a popular method of organizing wireless networks topology in which few nodes, the cluster head are elected as representative to route the traffic originate in the entire network. This one is the group the IoT devices into clusters. Group the IoT devices into clusters. Out of these IoT devices, one device acts as a cluster head. This is the cluster head. The cluster head has responsibility is receive the information from the nodes, cluster nodes like that. In this way, how to reduce the energy consumption of the each and every IoT device. Clustering is a proper method of organizing wireless network topologies in which few nodes, means these are the few nodes. The cluster, this is the cluster head. Cluster head are elected as representative to route the traffic originated in the antenna. Cluster head only has responsibility to receive the data from the IoT device within the cluster and route the information to another cluster or to base station. These are the responsibilities of the cluster head. This is the clustering. This is the cluster. This one is the two circles. Cluster head, dots, black dots, sensor node or IoT device. This is the flow of data. In this cluster, 3 IoT devices are there, or 3 sensor nodes are there. One cluster head is there. This is the cluster head. These 3 IoT devices send the data to cluster head. Send data to cluster head like that. Here, 4 IoT devices are there. These 4 IoT devices are send data to this cluster head. Here 1, 2, 3, 4. This is a cluster 1. This one is a cluster 2, cluster 3. This one is cluster 4. Here CH1, CH2, and CH3, CH4. Cluster heads are receiving the information from the IoT devices in cluster 1. CH2 has the ability to receive the information from the other sensor nodes or IoT devices like that in cluster 3 and cluster 4. These cluster heads, CH1, CH2, cluster heads for cluster 2, CH3 cluster heads for cluster 3, and CH4. These 4 cluster heads in this network, IoT network, has a responsibility to receive the information from the sensor nodes and send the information to base station directly. Instead of sensor nodes send the information to base station, cluster heads has a responsibility to send the information to base station. Finally, the energy consumption of that sensor nodes or IoT devices is reduces. Therefore, the lifetime of that IoT devices are increased. Clustering is an efficient technique to improve scalability and the lifetime of IoT network. Scalability means add no devices to the new IoT device to the clusters. It is very easy compared to other techniques. Increase the lifetime of IoT networks. Clustering sensor nodes is the most effective tool for energy saving among them. Okay. It does not generally need a special support for low power hardware and thus more flexible and can easily adapt to various environment scenarios. Devising clustering algorithms have been extensively researched for energy efficient IoTs. Okay. The clustering approaches of IoT are more hierarchical, using cluster heads as the decentralized authorities for realizing mostly star or tree topology. This is the cluster head. Receive the information from the cluster nodes. This is the star topology. Tree topologies are also used. Tree topologies here in the tree topologies. This one is the star topology. In tree topology, another cluster is there like that. Hierarchical structure. 2 types of topologies are used: star topology and tree topology. In IoT vary in their objectives. They are existing approaches aiming to fault tolerance, load balancing, energy consumption, increased connectivity, and reduced packet delay. With the help of that clustering, you have to achieve all these things. Faults are easily identified in the cluster. If any node is in default condition, not involved in communication within the cluster, that fault is easily identified. That is called as fault tolerance. Load balancing means instead of all the nodes send the information to base station, only cluster nodes are send information to cluster head. Cluster head has responsibility to send the information to base station. That is called as load balancing. Energy consumptions. Suppose this is the cluster. This cluster is in active condition. All the cluster nodes are also in active conditions. Since the environmental conditions develop the data is sent to cluster heads. Once the task is completed, these cluster nodes are converted into a rest mode, not involved in any communication. That is the reason energy is not wasted. Okay, this is the energy consumption. Increased connectivity and reduced packet delay. Increased connectivity means only cluster nodes are connected to cluster that particular cluster head within the cluster. Therefore, connectivity is also good. Next, clustering in IoT. In cluster-based architecture, the sensor nodes are divided into several groups are called clusters. Every cluster would have a ladder, often referred to as cluster head. Each sensor node belongs to one and only one cluster. This one is the cluster. These are the sensor nodes. This one is cluster head. In cluster-based architecture, the sensor nodes are divided into several groups are called as a cluster. This is the cluster. Every cluster would have a ladder, often referred as a cluster head. This one is ladder. That is called as cluster head. Each sensor node belongs to one and only one cluster. This is the sensor node. This is the sensor node. 1, 2, 3, 4, 5, 6. These 6 nodes are belongs to that particular cluster. Okay. The sensor nodes inside a cluster collect the data and communicating with their cluster heads only. These are the sensor nodes involves collect the data and communicating with respect to cluster heads only. This is the data flow. The cluster heads then aggregate the local data to discard the redundancy, uncorrelated data, and send to the sink directly via other cluster heads. This is the base station. This cluster head receives the data from the cluster nodes, analyze the data. If any redundancy is there, remove the redundant data. Any uncorrelated data is there, the data is also removed. And finally, set important data to base station. That is the procedure. In many IoTs, cluster heads are usually elected among the normal sensor nodes, which can die quickly due to extra workload for data aggregation and data forwarding with their limited energy. This one is the cluster head. Cluster head has has ability to process the data, receive the data, send the data like that. It has ability to engage all the things. That is the reason. That is the powerful node. It has a high energy capacity. It has high energy capacity to perform all these tasks compared to other cluster nodes. Cluster normal nodes. Sometimes, most due to workload or workload conditions, the energy is consumed most of the times. This cluster head is die out. In that scenario, I have to face some problems. In many IoTs, the cluster heads are usually selected among the normal sensor nodes, which can die quickly due to extra workload for data aggregation, data forwarding with their limited energy. In that case, that cluster head is died out. We have to face some problems. A cluster-based IoT has the following advantages. As only one representative per cluster needs to be involved in data aggregation and routing process, therefore it reduces the energy consumption significantly. Only cluster head is responsible to route the packet, receive the packet, processing the data. Okay. Due to these conditions, the energy consumption is reduced. It preserves communication bandwidth. Preserves communication bandwidth, as the sensor node needs to communicate with their cluster heads only, and avoids exchange of redundant messages among them. Only cluster heads are responsible. Therefore, bandwidth, it preserves communication bandwidth, as the sensor node needs to communicate with their cluster heads. Only sensor nodes are communicate, or IoT devices are communicating with the cluster heads. The clusters can be more easily managed, which in turn improve the scalability of the network. significantly. Issues. The most crucial point is that if the sensor nodes are not properly assigned to their cluster heads for cluster formation. Suppose if the sensor nodes are not properly elected the cluster head, therefore the cluster head is not has the ability to perform all these tasks. In that scenario, you have to face some issue. Some cluster heads may be overloaded with the high number of sensor nodes. Suppose the cluster head has capacity to communicate with 6 cluster nodes only. Okay, out of instead of 6 cluster nodes, 10 cluster nodes are forcibly assigned to this cluster head because of scalability. Because of scalability, extra 4 nodes are added. In that scenario, some cluster heads may be overloaded with high number of sensor nodes. Such overload may increase latency. Latency means delay in communication and degrade the overall performance of the IoT networks. IoT is nothing but WSN, IoT networks. Load balancing is the most important issue for clustering the sensor nodes. Suppose instead of 6 nodes, 4 nodes are added due to scalability of that IoT. The 10 nodes, total nodes are 10 nodes. It is very difficult to receive the information. The cluster head receives the information from the 10 nodes instead of 6 nodes. That is the load balancing is the most important issue for clustering sensor nodes. Designing clustering algorithm, one should take care not only the load balancing of the cluster heads, but also energy consumption of the sensor node to increase the network lifetime. This is the important point. Types of clustering. 2 types. That is intra-cluster, inter-cluster. Intra-cluster, within the cluster. In a cluster, this is the cluster. One node acts as a cluster head. This is the one node acts as a cluster head, and the rest of the nodes acts as the cluster members. These are the cluster members. All are CMS. CH is elected using election algorithm, like in our normal election, that is based on the energy consumption. This cluster head has a powerful and has a more energy. It has more energy to process the data, send the data, receive the data from the cluster members. Therefore, that node is automatically elected as cluster head. If energy level of cluster head less than threshold, then the new CH selection. This cluster head energy is less than threshold energy. In that case, this cluster head is out and takes place new CH selection. This one is the intra-cluster connectivity. Intra-cluster connectivity means within cluster only. Within cluster. Blue color indicates the cluster head. These are the cluster members. 1/2. This is the star topology. 1/2 means the distance between this cluster member and cluster head is 1/2. Directly, these nodes are directly send information to cluster head. In multi-hop intra-cluster connectivity, here this one is the cluster member, not cluster member. Cluster head. The remaining nodes are not directly connected to cluster members, are not directly connected to cluster heads. This one is the multi-hop connectivity. This is called as multi-hop connectivity. Multi-hop intra-cluster connectivity. Inter-cluster. Another technique is inter-cluster between cluster head. One technique, and every cluster head and a sink, another technique. In inter-cluster technique, these are the cluster heads, blue colors. 4 cluster heads are there. These in this region, in this cluster. This is the cluster 1. This is the cluster 2. This is the cluster 3. This one is the cluster 4. CH1 cluster head belongs to cluster 1, CH2 cluster head belongs to 2, and similarly 3, CH3 2 for 3, CH4 for 4. Overlapping regions are there here. Some overlapping is there here. Here some overlapping is there. These cluster heads are responsible to send the information to base station. These cluster heads receive the information from the cluster members. Green color indicates the cluster member. This is called as inter-cluster, between cluster head. Between cluster head. Every cluster head and a sink. In this case, every cluster head and a sink. These cluster heads are receive the information from the cluster members and finally send information to base station. This is called as one hop towards the sink. Coming to between cluster head. In second scenario, cluster heads are not directly send information to base station. Instead, these cluster head CH1 send the information to common gateway node. The common gateway node is sent information to CH2. The CH2 is sent information to distributed gateway. After that, these distributed gateway send information to CH3. Then CH3 only send information to base station. Instead of CH1, CH2, CH3, and CH4 send information to base stations. These CH1 send information to CH2 through common gateway. This is the common gateway node, and the CH2 send information to CH3 to distributed gateways. Then CH3 send direct information to base station. This is called as multi-hop inter-cluster communication. Finally, the main aim of that cluster principle is reduce the energy consumption of that IoT devices and therefore increase the lifetime of the IoT devices used in IoT networks. This is the theory behind the clustering principles in IoT devices. Thank you.